Well, folks, this is Guruji online, and I am Sanjay speaking from this platform. Today, we are going to solve some problems pertaining to Carnot cycle. So, this is one figure, and it is showing a Carnot cycle. It is a graph between pressure and volume. So, we have to calculate in this the work done, the energy added in the stroke ABC, that is this, and efficiency of the Carnot engine. So, and this is pertaining to basically monatomic ideal gas is there. So, what is the, let us do one by one, what is the work done? Work done, we know it will be the area enclosed by this cycle. Any doubt? So work done, we can straightway write what is this? This is V0 and this is P0, because this is 2P0 minus P0 and 2V0 minus V0. So this is work done, we can straightway write, that is, this is the work done. Now let us find out what is the energy added during this ABC, means this cycle. That is Q, we can write it as N for number of moles. During this AB process, it is at constant volume, delta T, or we can write it as TB minus TA. Correct? During this process, this much energy will be added. Now, what about BC? It is at constant pressure, and here it will be TC minus TB. Correct? To simplify this, let us write down some equations for A, B, C, D. It is an ideal gas. So for A, it will be P0, V0 is equal to N R TA. For B, it will be 2P0 into V0 is equal to N R PV. For C, it will be 2P0 into 2V0 will be NR TC, and for D point, it will be P0 into 2V0 NR TD. This is 1, 2, 3 and 4. Correct? Now let us simplify this. And CV for monatomic ideal gas is nothing but 3 by 2R And suppose if we take TA as common, then it will be TB divided by TA minus 1 plus N. For monatomic gas, Cp will be 5 by 2 R into TA, and it will be nothing but Tc upon TA minus Tb upon TA. This I have done for the simplification. So now let us make N from this R and this TA. We take common. Then this will be 3 by 2. What is TB upon TA? TB upon TA will nothing but 2 minus 1 plus and RTA we have taken common. So this will be 5 by 2 into what is Tc upon TA. Tc upon TA will nothing but, it will be 4 minus Tb upon TA, that will be 2. So this will give you, this is what? This is nothing but, that means we can write it as P0 V0 into, this is 3 by 2, this is plus 5, 2 by, this will be 13 by 2, means this is 13 by 2 P0 V0. So what is the efficiency? That we know, W upon Q, energy added, W upon this, and this will be nothing but this upon this will give you 2 by 13, or we can write it as this will come as 15 by 6, 15 by 15.4. This is the efficiency. So we have solved this, we have solved this also, and we have solved this also. Now it is saying if engine is operating between highest and lowest temperature, what is the efficiency? So what is the highest temperature? Highest temperature we can see from this equation, it is Tc, and lowest temperature we can see from this as Ta. So this portion, this will give you an 1 minus Tc upon Ta. Tc is 1 minus, Tc is nothing but PV0, P0, V0 and RT, they are all common. So we can write it as this is Ta upon Tc. from lowest temperature, highest temperature. So this will be 1 by 4 and this will give you a 75%. So this is the solution of this problem. This is how you can find out the work done, the energy added, the efficiency of the Carnot engine once we are given a graph of one cycle of the Carnot engine. Now we will go to the next question. So this is the second question. In this question, this Carnot cycle is given and these two processes are adiabatic processes. Means no heat is coming, exchange currency between these two processes during these two processes in the system. So we have to find out, number one, whether gas is monatomic or diatomic, and then we have to find out the efficiency of engine. So these are two adiabatic processes, so the variation will be P0, V0, that is between D and A. This is for D, it is P0 divided by 32 and V0 here is 8 V0 and that is must be equal to, for A it is P0 and what is V0? So we can find out, this will give you 8 gamma is nothing but 32, or we can write it as means gamma is 5 by 3. Sorry. Yeah. Gamma is 5 by 3 means, and this shows this is a monoatomic gas. Now let us find out the efficiency of the engine. For efficiency we have to find out the Q added and Q exhausted. In these two processes there won't be any addition or exchange of gas. So for if the process A to D, Q added is N, it is a constant pressure process, and this is TB minus TA, and this is nothing but N. For Cp, you already know it is 5 by 2 R for monatomic gases, and here we can take it as Ta, and this is nothing but Tb upon Ta minus 1. Now Tb upon Ta, Tb upon Ta will be nothing but, it will be we can write it as, for A it is P0 V0 is equal to N R T A, and for TB P0 V0 N R TB. Here actually for B it is 2 this thing. So this will be nothing but TB upon TA will be nothing but 2 minus 1. Or we can write it as, this thing we can write it as NRTA is nothing but P0 V0 into 5 by 2 2 minus 1, or we can write it as 5 by 2 P0 V0. Like that, for C to D, this is Q, exhaust, how much energy is released, and Cp Tc minus, Td minus Tc. Here again we can put N 5 by 2 R into this is Td, we can Td 1 minus Tc upon Td, and this we can write NRTD is nothing but P0 V0 P0 upon 32 into 8 V0 into 5 by 2, and here it will be nothing but 1 minus 2. So this will come as minus 5 by 8 P0 V0. Now efficiency is your 1 minus Q added divided by Q exhaust. Sorry, Q added here, Q exhaust here. QL upon QH. And this will give you 1 minus 1 by 4. And this will be nothing but 75%. So this is how you can solve from this graph and find out the efficiency of a Carnot engine. And you can find out the gas also, whether it is monatomic or diatomic. So now we will go to the next question. This is the third question. and it says the efficiency of a car engine is 30%. When the Indian engine does the work of 10 kilojoule per cycle, find the heat gain and loss per cycle. And suppose the engine is tuned up to 40% efficiency, what will be the heat gain and loss for the same work? So in this case, actually efficiency is given, work done is given, we have to find out the heat gain. So heat gain is nothing but efficiency Q W here W is given 10 and efficiency is given 30%. So this will be nothing but 33.3. Naturally, what will be the heat Q lost? Q gain minus W, it will be 33.33 minus 10 will be 23.33 K. Now the second part of the question, that is, now the engine is tuned up. Suppose engine is tuned up to 40%, then what will be the Q gain? Work done is same. It will be 25 and what will be the Q lost? Will be 25 K J minus 10 . So you see these values are drastically changed once you increase the efficiency of the engine. So now we will go to the fourth question. Let us see. This is our fourth question. Basically, this is a two-stage Carnot engine. In the first stage, this Q1 energy is absorbed, W1 work done is done by the engine, and Q2 energy is expelled. And this expelled energy is at temperature T2. Q1 was at temperature T1. This expelled energy is then absorbed by the second stage, and W2 work done is done, and this Q3 energy is expelled at temperature T3. So we have to find out the efficiency of this two-stage Carnot engine. So basically, from the basics, we know what is efficiency. What is output? Output is basically W1 plus W2. Correct? This is what this Carnot engine is doing. This is giving this W1 plus W2 as output, and this is what we are interested in. And what is input basically? Input is nothing but it is basically Q1. Initially, this was the energy we had given. So, this is basically the efficiency. But we have to find the efficiency in terms of temperature. So, this will be W1 will be nothing but Q1 minus Q2 and W2 will be nothing but Q2 minus Q3, and this will remain as Q1. This can be simplified as Q1 minus Q3 divided by Q1, or we can write it as Q3 upon Q1. But this is in terms of heat, energy. But we have to find out the efficiency in terms of temperature. So let us go back to our entropy session where we had find out our entropy is nothing but delta Q upon T. And this we had, in this we have seen that Q H upon TH equal to QL upon TL. With this analogy, we can write it as Q1 upon T1 must be equal to Q2 upon T2 must be equal to Q3 upon T3. Correct? If you can't understand this step, please do write in the comments. In my next video, I can give you the solution. Now, Q3 upon Q1 is nothing but this efficiency will be T3 upon. This is our answer. It was very simple. The only thing is we have to understand clearly what is to be done. Basically questions remain very simple unless we understand them. And this is what we have to see through the questions, how we can understand, how we can crack the questions, how we can solve the questions. So these were some few problems regarding Carnot engine. In my next video, we will come with some more questions, some important questions with respect to your exams. So please, if you like this video, please do subscribe my channel, and thank you for now.